All right. Thanks a lot, everyone. I hope you're caffeinated enough now. This is my first ever Kamailio World, so thanks a lot, Daniel and everyone, for having me. As Daniel said, I've been around for a little while. Actually, he may not remember, but the first time we met was at 2007 at Vaughan in Rome. He was giving an OpenShare admin course. Boy, time flies. So today, I'm going to tell you all about Jitsi. Quick show of hands, who here knows about Jitsi already? All right, a few of you. So one thing that I gathered yesterday was that not everyone knows some of the changes that have happened. For those of you who don't know what Jitsi is an open source suite of software for video conferencing. I know not everyone likes meetings and stuff, but since you need to have them anyway, might as well be in HD, which is what we try to do here. And a couple of years ago, Jitsi got acquired by Atlassian, and we are part of the family, let's say. And this brings, well, the Jitsi software to some of the Atlassian software, and it also brings some challenges on us, and some of them I'm going to show you today how we solve them. So the first sort of place where we integrate Jitsi is in Atlassian's proprietary team communications software called HipChat. So in there, the video part is all powered by Jitsi, and is the same thing as the open source part because it would be too hard for us to maintain two things. So it's just, let's say, a skin on it. Another thing we do for Atlassian is manage our company-wide all-hands meetings. They happen every week, and all the offices are connected. Presentations are given by the CEOs. So as you can probably imagine, it's kind of a big deal to keep this thing up. Otherwise, someone will want to kill us. Scalability and stability are at the core of what we need to deliver. And another of the things we need to do is we are the stewards of the Jitsi open source project. So we host a bi-weekly call with the community where people can suggest features or share their pain points with us. An example of how this, one of the things that has happened is that 2 years ago, the Jitsi desktop client transitioned into a community maintenance. So people from the community are contributing patches and keeping that while we focus on the WebRTC and web part of the entire deal. So it looks like this, which when I took the screenshots, other than realizing I have too many tabs, I thought, so it doesn't look that impressive, you know. There is this one video there, which is Yana, that Daniel mentioned, and a bunch of guys here. This is our daily stand-up. So I could spend half an hour here sort of telling you feature by feature what it is, but I thought I would do it a little bit different and show you a collection of features that I think would make the conferencing experience better. So while I'm telling you this, you may want to try this yourself. So you can go to that URL, meet.jit.c, and you can start your own conference. There's no registration, no nothing. Everything is ad hoc. And you can also self-host it. So this is an instance we host for the people in the community, but you're free to install it in your own system. We're going to see it, and I may try to demo that, Dangerous Demos as well. So let's see what powers this baby up. So what I came up with is this idea of what does it mean for a conferencing experience to be great, and what feature sets we want in our application to make it good. So first thing is availability. So works only in Chrome is not going to cut it anymore. You got to go everywhere so that people can use your conferencing application wherever they may happen to be. We support the 4 major browsers, so Chrome, Firefox, Safari, and, well, Internet Explorer, hopefully not for long. And so Edge here is sort of grayed out because we're working on it. We actually hired my good friend Iñaki to work on the Edge support. And once he's done, we will have first-in-class support for Edge. Some of you may think, but Edge said they support WebRTC 1.0. Well, you may have been deceived. So it doesn't support data channels. It doesn't support multiple streams, which are essentially an integral requirement of a multi-party video conference. So that's why we are working on it. We also have an Electron app for those who like a desktop kind of thing. And we have also been focusing lately on our mobile apps via React Native. They are both available in their respective stores, and they are also open source, so you can build them yourself. But you don't need to if you trust us, because you can run them targeting at your own deployment. So if instead of pointing the room name at, Kamailio or whatever, you put a full URL to your server, or you use our special link with the scheme or Jitsi Meet and then your server, you will be taken directly to your instance of Jitsi Meet instead of connecting to the publicly available one, which is the default. So if you don't want to install anything, they just work. If you do want to have your own deployment, they also work, which is what we're aiming for here. Very important thing, of course, when you do a video service is it has to be scalable. Yesterday, at Matthew's talk, we heard that Asterisk is going to have multi-stream support, and that the app conference is going to switch into this mode in which it forwards the media instead of mixing it. That is what a selective forwarding unit, or SFU, is. And the Jitsi video bridge, which is the heart of the video part here, is exactly that. So there we have, like in this example, 3 endpoints, which are each of them is sending one stream and receiving all the others. So this gives the flexibility in the client to render the way you want, because you get access to all the streams. And it also makes the server simpler. Well, it still has a lot of meat in it, but since you don't have to mix video, which is something very costly, you can scale up a lot easier. And this has become, let's just say, the de facto, let's say, way of doing multi-party video conferencing in the recent past. Now, in addition to that, you want some sort of dynamic video delivery technology, because when we're looking at the image before, we had Yana on the large screen and then a bunch of thumbnails. It would be very wasteful to use HD and like 30 frames per second for those tiny thumbnails. So what we do is we combine simulcast and SVC, which are 2 technologies to be able to scale the video up and down. Simulcast consists on sending more than one video stream from the sender side. So to the server, we send 720p, VGA, and then the little thumbnail. And the server will pick which of these 3 layers to forward to each of the other participants in the room based on their needs. So if they have you on the largest screen, they will send the HD version. If they have you on the thumbnail, they will send you just the thumbnail. And SVC, or scalable video coding, is a way in which a user sends one stream, and then just by stripping a few packets, you end up getting either different resolutions or different frame rates. VP8 supports temporal scalability, which is different frame rates. So when we use VP8, we're using simulcast for the different resolutions and SVC for the different frame rates. So you can imagine that having a thumbnail be the small resolution and at 15 frames per second, for instance, saves some processing and some bandwidth. This is something you really want to have if you want to have a very large conference. And it doesn't need to be all that large for it to start running into your CPU wanting to jump off to the swimming pool. Like in our weekly stand-up, well, our daily stand-ups is usually like 13 people connected at the same time, which is quite taxing on the CPU. Of course, with the advent of mobile and everyone joining from, well, flaky internet connections sometimes, you want your server to adapt to these varying network conditions and whatnot to give you the best possible video experience. So one way we solve this is, we call this adaptivity, which is we measure the bandwidth and try to give you as much video as we can, but just so you can process it. So for instance, one of the things we do is called last N, and it was written by a couple of colleagues of mine. There's a white paper somewhere. And basically it boils down to the server will only forward you the last N most relevant videos. And N being, if you can do 2 videos, we will do 2 videos. But if you can't do more, we'll just give you the last 2 persons that spoke. so that you at least get the ones that are actively participating in the conversation in principle. And this N will enlarge and shrink based on the detected bandwidth. So as much video as we can give you, we will, just little by little. Of course, it has to be simple to use and to install, because if something is very complicated, people are just not going to use it. So with that command right there, if you have our repository on your apt thingy, apt install Jitsi Meet, and everything is installed and everything is configured, you will get asked 2 questions, which are like, what's your domain and where is your SSL certificate? However, if you don't feel like pointing the thing to a given cert because you don't have one, we recently integrated with Let's Encrypt, and Ole has nothing to do with it. And we did it so you install it and you get this no warnings conferencing experience, because usually when you deploy it and you don't have a cert, it's like, oh, damn, it's a self-signed cert. So you get the warning in the browser. Mobiles don't work because unless you add it to the trusted store, they will just refuse to connect. And it's overall not a great experience. So we try to make it as simple as possible. And with that single command, you will get what I'm telling you. So what you just saw and what you're about to see with just one command. Of course, it has to be open source. I mean, I doubt anybody in this room is thinking otherwise, but whatever solution you're aiming for, integrating into your existing stuff or building a new one, I always believe open source is the answer, because in the end, open always won, and companies get taken over, go down, go up, but at least the code lives on. And on this note, I think it's also great to foster friendship. We had Fred tell us all about how he loves Kamailio because of its community. And we love the community around WebRTC, video conferencing, Kamailio, and everything. And I mean, and we have 3 kind of competing SFUs depicted here. Lorenzo from Janus, Iñaki from MediaSub, me from Jitsi, having some nice pizza in Amsterdam and debating ideas on how to better do things. And this just helps everyone. So this is something I personally care about, and I'm very happy to, for example, be here and exchange all these ideas with you guys. There's a million other little things, like there's some chat we're going to see about recording. You can invite people just by sharing the URL. But, one has only a limited set of time. So I am going to mention one, though, that we did recently. And we could do this because we had some numbers. And we had some numbers because we measured, and because we also see what people are doing both inside and outside Atlassian. And this is the peer-to-peer call path optimization. So we saw that out of all the calls in the meet.jit.c service, 50% of them are one-on-one calls. So for those calls, what we did is, if a call is one-on-one, we will establish it over the video bridge, because if a third person joins, you get the video from everyone. But if there's only 2 of us, then we could try to do it directly. And then we don't involve the bridge. We will potentially have a lower latency connection. Will be less bandwidth usage for us, which I guess kind of goes in line with what Tim was saying yesterday as well, trying to save up on their turn server. And we have seen 85% of success in these peer-to-peer calls. This is out of those 50% that are one-on-one. So pretty good. That means we pay for less bandwidth, and potentially people get a better experience. And the moment a third participant joins, or that connection dies or whatever, we just fall back into the connection that is already open via the video bridge, though we're not sending anything while we are doing it on the peer-to-peer one. And we just continue like nothing happened. Little hiccup, and we just continue with the conversation. So at this point, you might be wondering, so Kamailio is all about SIP. Saúl, where is the SIP in your talk? And it's coming right now. When you will always want to talk with some SIP endpoints, because that is what's deployed today. And you can't, even if you like to live in this sort of wonderland where WebRTC is all the rage and blah, 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 that's cool and all. But you got to talk to the SIP devices out there. So how do you do that? We have a component for it called Jigasi, or the Jitsi gateway for SIP, that allows us to connect in audio-only mode with SIP devices. It looks pretty much like this, which is here we got the video bridge right up here, and he's sending all the multiple streams, this is important, to Jitsi. And Jitsi is basically like the Jitsi desktop client running in like headless mode. And then he does all the mixing here and interacts with SIP endpoints down here. So one of the things we wanted to actually kind of solve is, if we have to do this mixing, that is taxing on the CPU. This is potentially a scaling problem. We have a way to run every component in the infrastructure, scale it horizontally, so just add more of those. But generally, it's not something we would want to do, mix a lot of audio. So how do we solve it? Well, in this case, we use a third-party provider, though no endorsement here, is Box Implant. And what we do is we sell the multiple streams to them, and then they can do the mixing for us. So they take care of the burden. Now, yesterday, Matthew said, hey, Asterisk is getting multi-streams and SFU support. So I'm like, that's fantastic, because we could send all the streams here to an Asterisk server. He could take care of the mixing. They are experts in that. And we could add more boxes if need be, and job done. So maybe that's something we do in the future, or maybe that's something you do in your deployment. So it has been great to learn about this new thing in ways of scaling this up. So let's see if it actually works. And the Wi-Fi cooperates. So that URL there is my little development machine. You're all welcome to try it and join me while I'm here. So we're going to try dialing out to a SIP device. We have a button here that shows up only when you have a Jitsi component deployed. And I also have a SIP client running here, a stranger to me. So I dial a SIP address, and with any luck, yes, I get an incoming call. And upon answering, Blink is connected to this conference room via Jitsi, which is doing all this mixing, and all Blink is receiving is just audio only. But, and let's hang up here. Thanks for pushing it, guys. I could also try to, where am I again? There we go. So I could also call in via a PSTN phone number that is in France. And there should be a new participant coming up, which has, there we go. I think it's this guy, yeah. So his username is my phone number. So it's from the PSTN. The idea being, you're hosting a conference and people can call in, call out. We are actually rolling this out to meet Jitsi, so people can also try it. It will be in some limited capacity. Oops, I didn't close this thing. We can see adaptivity kicking in. Video has been turned off to save bandwidth, for example. So anyway, we're back here. So the idea here is whatever world you're in, the SIP world, or you're in the WebRTC world, you can still join the conference and have the best possible experience. It may be, no video because you're in an audio-only device, but that's also fine. We can work with you. Now, as we heard on yesterday's panel here, it's all about video, I guess. I myself found using video every day is like a good thing these days. So how do we actually do this but for video? Let me take a quick detour and show you how we do recording first. And this will explain half of it. So the way we do recording is by streaming to YouTube or other video services, and then they can take care of scaling this up or archiving the recordings and so on. And how does it work? Well, so we have Selenium here, which spawns a Chrome instance. And this Chrome instance joins the conference in like hidden participant mode, so you can't see him, but he's just an observer right there. You can toggle a switch to follow the moderator, so the moderator of the conference, whatever it does on the interface, the recorder follows. And then we use FFmpeg to record the entire screen and just pipe it over to YouTube. And then YouTube takes care of live streaming, people can join, there is this interactive chat, blah, blah, and it does the archiving for us. So this is how we solve the streaming problem and the recording problem, 2 for the price of 1, and we even sort of offloaded to YouTube for the most part. All this runs in a VM that we spawn on demand, so you can either have something in standby or spawn it on demand, that's fine. So it's not like a resource that you need to be consuming all the time. Now, how do we do the rooms? The rooms is the problem we try to solve, and the thing where sort of being at Atlassian kind of meant that we wanted to solve this problem. There's a bunch of video rooms at Atlassian with life-size hardware. And you know, you can't get 10 people around the laptop trying to see something. They seem to want to gather in a room and then connect some remote people into the conference. So how do we do that? Well, the hard way. So this line here separates 2 different X servers running. One X server spawns with Selenium a Chrome instance that joins the conference. The other X server uses PJZip command line client with very slight changes so that it always shows video in full screen to call that life-size device. At the same time, and in the background, we have FFmpeg capturing the output of this entire X server. And guess what? FFmpeg has this little cool thing that it turns a display, a full display, into a video for Linux device. So you have like a webcam, dev video 0, that you can use as an input anywhere. Well, we use this output as the input of the other guy, and the other guy's output as the input of this guy. And we do the same thing with some ALSA loopback devices, and well, boom. So you wouldn't believe how good this works. In pure Unix style, a little tool for the job and all duct tape together. It's like Dan said yesterday, it works like magic, different kinds of magic, but kind of like that. And because doing a demo here is going to be complicated, I'm going to show it to you. And Daniel Mierla has the mic. Can I have the mic? Because there's no audio output to the thing. So I'm going to try to show this to you live later, but all right. So let's just see how this looks like in practice, narrated by Emil El Jefe Ibov. Damn, volume. Audio device. So that. There we go.
If you want to have multiple people participate in the same conference from the same location, you can't just put them all in the same laptop. You need video rooms with dedicated video equipment. There can be different brands and models of equipment.
Come on. Why is this thing showing? Let's start from the top.
If you want to have multiple people participate
voice,
in the same conference from the same location, you can't just put them all in the same laptop. You need video rooms with dedicated video equipment. There can be different brands and models of equipment, but in our case, it is predominantly life-sized, and it does provide superior audio and video quality for our video rooms. The issue, however, is that this device is pretty much like any other brand on the market, relies on a legacy way of distributing video. Rather than using the lightweight, novel video routing approach, life-size Cisco and Polycom devices relied on the heavyweight mixing. Now, I'm not trying to say that one is inherently evil and bad while the other is just good and fighting for a better world, but it is very hard to get them to talk to each other. In order to do that, one basically needs to take the multiple VP8 video streams that come from the Jitsi side, transcode them, mix them, and only then send them to the life-size side of the picture. A similar thing then needs to happen in the opposite direction. All in all, it is a complicated story. Luckily, we already do half of this in our weekly town hall meetings where YouTube expects us to send a single H.264 stream. So we only needed to code the other side of this. As is customary for Atlassian, we started by assembling a kick-ass team of video engineers. Saúl, Aaron, Jana, Pavel, Damien, we all got together and rolled our sleeves. Now, let's see what we came up with. It all starts just as any other HipChat video call. You get into your conference and meet all the people you want to talk to. Then, let's say that in the middle of the conference you would like to add a video room to your conversation. All you need to do is press the new plus button in the side toolbar. Right there. Next, you type and select the name of the room you'd like to call. A shout out to the Atlassian team for providing a beautiful user picker. When you hit enter, the Jitsi backend will send a SIP call to the room of your choice, and it will make it ring, just as it would with regular room calls. Then, as soon as the occupants of that room are ready to answer, Jitsi will connect your call. Et voila, the dedicated room is in your call. Isn't that swell?
Thanks, Emil. So that was that. As you saw in that sort of video, the idea is how we ended up bridging to these SIP devices that we needed, and well, this is our solution. That's all I got. And if you have any questions, now is the time, or I'll be around. I have one here.
Here, one.
Okay.
Where
my
is-
question. Yeah, my question would be from. I was working with Polycom, these legacy systems, and they are all about talking about the low latency in the video. So it's like milliseconds of video latency. And what about video latency in Jitsi?
Well, so here you can imagine the way this is working is essentially just like calling another endpoint, which in our case, it's like a PGSIP command line client. So you get the latency you would get, the same latency you would get, because the way we pipe the video is by capturing the whole screen with FFmpeg. So that doesn't introduce latency. It's being captured at 30 frames per second nonstop all the time. And you just pick the video from there. So it's not like we're not doing the synchronization at the, let's say, media level. It just happens because your webcam is not what you think it is, kind of. So we haven't seen any problems in latency like this. And actually, all the more, in our case, our infrastructure is based on AWS. And we are adding these machines to the core networks so they have direct access, like a laser, direct IP access to the rooms, to even reduce one hop and no need for proxies or anything. We can do direct IP calling. But the call itself doesn't inherently add any latency. It's just another SIP call. It doesn't look any special from the life-size side of things.
Okay, other questions there? Oh, no? Okay, so on the gateway with SIP, it's any feature lost, or like it's just like probably just being participant, but
In the video one or in the audio one?
in the video.
In the video one, well, of course, you lose the ability to select, for example, even if the active participant, you don't want to see him, you want to change to somebody else, you're an spectator in that degree. You cannot like click on the interface. But because the default way of working is that we switch to the active participant, you will just keep seeing that switching. And we apply some heuristics to try not to switch very often, you know, especially when two participants are talking to each other. So the switching should be pretty smooth. Also, let's just say that someone uses another feature we have, which is Etherpad document collaborative editing. You, of course, cannot edit the document, but you can see the others edit the document. And this is also one of the strengths of doing it this way, because if you try to do, like, for example, an MCU, well, this is not a video stream, so you can't really encode that thing. You would need to do special casing for every single little button in your UI. So the way we dealt with it is, well, if we take the UI as is, which is the experience we designed, and that's sort of what you get on the video side, as much as possible. And video being the main focus, you at least get that. And if someone shares this screen, it's another video stream, so you'd see it just the same.
Okay, then thank you, Saúl.
Thanks.